In this demonstration, we'll see how the software for the avionics subsystem is developed. As we saw in the architecture management part of the demonstration, there was a handoff between the Hummingbird system and the avionics subsystem, and that handoff consisted of a package of model elements along with the requirements for that subsystem. Let's open those software requirements in Engineering Requirements Management. In the avionics software model, these requirements are further elaborated, starting with a use case analysis. And here we can see the use cases in that model that are traced to these requirements. Rich Hover allows us to view model diagrams, such as this use case diagram right here in Requirements Management. Let's follow that link into Rhapsody Model Manager, where the models are stored. Here, of course, we could start navigating around this avionics model using the web browser. But instead, let's open it in the desktop client. The specification model for the software is now built incrementally in a use case driven approach. We'll see that in a second, but all of that work has to be planned and tracked. To facilitate that, each use case becomes a user story in the team management area of engineering workflow management. Here in the model, this table view shows that mapping. Let's follow this station keeping user story into engineering workflow management and take a look at the agile plan for the avionics. Here is that user story, filed against the avionics team and planned for Sprint 1.2. Here on the Links tab, we can see other linked artifacts, such as the software requirements and tests, the use case in the model, and a change set containing the source code that was later developed and linked back to this story. We can also see that the station keeping story is a child of the manually directed flight feature in the program management area. Lastly, we can see that this story has a dependency to one of the other user stories, Rotate. Now in a moment we'll see how we can visualize and manage such dependencies. If we look at the team's dashboard, then we can see the other stories in the Agile plan as a list, but also in graphs, by the team that's responsible, by sprint, and also by current status. As we saw a few moments ago, user stories can have dependencies on other user stories. In our case, for example, station keeping depended on the Rotate story. Let's take a look at a very useful feature for visualizing and managing those dependencies, the program board. This gives us a visual summary of those user stories rolled up into their parent features. It shows when those stories need to be achieved, and critically if there are any dependencies that might impact their delivery. Let's look at two examples in our Hummingbird program. Over here on the right, this box tells me that one of the stories underneath feature 2149, that's Manage Power, is planned for Sprint 1.3, and it's owned by the avionics team. And it has a dependency on an earlier story, one that is a child of feature 2148, which is manually directed flight. And that one is targeted for Sprint 1.1. Now that dependency is green, because that kind of dependency is absolutely fine. By the time we get to Sprint 1.3, that earlier story should be complete. Now, of course, we can filter out those kinds of dependency if we want to. But here in Sprint 1.1, somewhere under feature 2148, Manage Power, is a story owned by the comms team that has a dependency on another story that in this case is a child of the same feature, but that story is not planned to be done until a later sprint. What's more, that story is owned by a different team, the avionics team. Now that's a project risk. One of the really powerful features of this kind of view is not only that you can visualize these potentially complex dependencies, but the view is actionable. We can identify a project risk and we can do something about it. Let's expand this manually directed flight feature. And here we can see all of the stories underneath it. If we expand this one, Fly Under Manual Control, we can see the other stories that depend on this one. Now one of those is Red, Update Pilot Controller with Flight Data, because it's planned for an earlier sprint. In this view, we can reschedule either of these stories to fix that problem. Let's push the update pilot controller story out to a later sprint. Now the dependency turns green. We still have a cross-team dependency, but now it's much less of a project risk. Let's now return to Rhapsody and take a look at how the software is developed. Each use case is now analysed using other UML diagrams. For example, if we look at the station keeping use case, then we have sequence diagrams that describe the interaction between the classes in the software architecture. That architectural specification is built incrementally. Here are the classes, interfaces and relationships that contribute to the overall architecture whilst realising the station keeping use case. If we dive into another use case, update pilot controller, then we can see that the development of that use case further elaborates the architecture with additional attributes, operations and so on. A behavioural specification is developed using diagrams such as this state machine. And finally, of course, we get to source code. Rhapsody can generate production quality source code directly from the model, using both the architectural and behavioural descriptions. Here, as I click around the attributes and operations of the classes involved in station keeping, Rhapsody's code view dynamically navigates to the right place in the source code. If those model elements have been traced to requirements, then Rhapsody can even include that traceability in the generated code. Now, of course, you could also write source code manually and use Rhapsody purely for the specification of that code. Design-level debugging allows the debugging of the generated source code using the design diagrams, in the same way that systems-level models may be verified and validated through simulation. Whether the source code is generated from the model or manually written based on the specification in Rhapsody, the code is managed by engineering workflow management. For example, if we switch back to the web client, we can see the user stories right here on the team dashboard. If we open the station keeping story and take a look at its links, we can see the linked change set. Now, if we follow that change set link, we can see all of the source code that implements that story. Now, as we saw in the model, software development is user story based and incremental. For example, if we go back to the project dashboard and look at the update pilot controller story, that too has a linked change set. But this change set contains only the additional or modified source code artifacts from that story that contribute to the overall codebase. Since the story is also linked to the requirements, it essentially completes a traceability path from the code to the requirements. Now, it's also possible to link the code files directly to the requirements. Either way, what we have is an engineered system with a digital thread from requirements to designs to source code, managed and tracked by engineering workflow management and, as we saw in the other videos, tested by engineering test management, along with reporting and analytics.